Thank you for the invitation to talk at JConf Mexico 2020 with my topic Continuous Stupidities Did DevOps Fail? Well, I'm full stack Java developer, but since around 15 years I'm working mostly as a build, configuration, and release manager in huge Java enterprise platform projects. Um, in this time, I see a lot of things they could get better in the way of project automation and the software development process. So it's more a question about structures and also paradigms. And for that reason, I want to spoil a little in advance. Of course, DevOps didn't fail, but there are some things we could do better. So after we was thinking a bit what means DevOps, and we was clearing the way of semantic versioning because so many projects don't know what that means, semantic versioning, but they are having this in their documents that they doing semantic versioning, but what they are doing in reality have nothing to do with the definition of semantic versioning. And after this, I have a small other theoretical point: release, deployments, and delivery, because we have to distinguish those three words. What that means. From this, we can jump into the correct pipelines and how to automate them. As long the words are not clear, well, we could do a lot of mistakes or simply we complicated too many things. So, and then after this small theoretical block, we jump into practical issues. So I was collecting five topics. Usually, projects struggle. Um, when we was passing our theoretically practical journey, then we put everything together as a short lesson learned to see how we could avoid in our project DevOps problems. So then, as first, we should think about it. What means project automation? Because usually things that are easy to automate, they are easy things. But as much complex get your pipelines or your automation project, as much complicated is it. The problem is not to create the first automation. The problem is keep it alive and maintain it. So in this way, I want to remind to the sentence of Gardibourg: a fool with a tool is still a fool. So for us in configuration and build management, it is more important to understand the things behind and choose the correct tool for our needs. It's not a question to discuss if Gradle is better than Maven. Both are having good benefits, but the problem is understand both tools is understanding builds. Um, in that way, you would use both tools equal. For that reason, don't keep it too complex. Keep it simple, easy, and stupid. The KISS principle. So another question is what that means DevOps. When I'm talking always in projects with developers, they always have the sensation now they get more responsibility to do everything. But no, is not. Um, they should know some basic strategies and tools. For example, if you are dealing with Git or other source control management systems, you have to understand as a developer there are could occur some problems like merge conflicts, and you need to understand why they happen. Um, this problem is always the same. If it's CVS, very old-fashioned, sometimes you find in legacy projects Subversion, same, or in Git or Mercurial, doesn't matter. Every time you are running in a merge conflict, you have to understand what it is and why it is and how I could avoid it before this occur. So in that way, we are not needed to get to know as a developer how to deal with Docker. We don't need to create Docker files and optimize for security. We don't need to know what is Puppet, Chef, or other configuration tools, how to prepare test environments, and for that reason, you have a group. They are called configuration management, and they will support you completely. They have the knowledge about it. As a developer, you just have to know, okay, I have a build logic, I have a source control management system, and how to deal with it, how to run my project. Um, in this way, there I always recommend a book from 2011 by Jez Humble with the name Continuous Delivery. Is by the way the first time I was reading about the term DevOps, and he gave a lot of good explanations on how to work together, development and operation. Because keep in mind, when you are in a huge project like online banking, insurance, or whatever, you never, as a developer, have access to the productive system, or in short, operation, because there are security data. This data you will not reach. So, for example, if there is crashing something in production, um, you have to send a request for collecting the log files. The operation team is filtering the log files, take it out every important information they have to secure it, like payment cards information and other things, credit card information or personal data of clients, because as a developer you should not see that. um, in this way, DevOps, we are talking about the culture, how you move, how you have to transition from the development environments into the operating environments. And in this way, you can automate a lot. The question is just how. And for that reason, we want to jump in the first theoretical topic, semantic versioning. Because not only for operation, also if you're dealing with other teams in development, if you're dealing with test teams, the version number of your artifact is absolutely helpful. In that way, make it clear. And to have a clear, understandable version number, you could use the semantic versioning. So many projects I was joined, they use the term semantic versioning, but they don't live it, because they don't understand the increasement of the mayor means an API change, and why it's so important to label this API change with an increasement of your mayor. It's very easy, because if I use as a other team one of your artifacts in my source and I consume it, so I need to get to know if you have some incompatible API changes, because then I can understand, okay, there are some changes, I have to check my code base if I have to do some adaptations. Some projects, for them it's very easy to make the adaptation, but sometimes this could have a very huge impact. To make it more easy, it's very important to deal very well with the major API changes. And of course, what is it? The API change is if you are erasing or you're changing a class name, if you are changing or erasing signature of your method, then you have a complete different behavior, and this needs adaptations. And those adaptations you should get to know in advance before you consume. Not so critical are minor changes. Minor changes means this is just additional. Usually in projects, sprints corresponds with the minor version number. That means if I have new functionality without any changes of the API, I just increase the minor version number, nothing else. The patch level is optional. That means if I have a version number 1.0 is equal to 1.0.0. Because the first zero is not important to mark, but it's very important to understand if I create a release and I deliver for test, and the test team detects some issues, and I have to make a new release to fix this very important high issue, then I have a version number 1.0.1. And as much patches I have to deliver, as much knowledge I get, or as much information I get about my quality status from preparing the release. So it's very important to get to know. Now, yeah, and sometimes people say, okay, in that way I want to create a release candidate or alpha, beta. Don't do that. This don't help you, because you create an artifact called 1.0 minus alpha. Well, it's fine. This is also storage in your Nexus or Artifactory repository. When you already reach something called release candidate and you want to have the release, you have to prepare it well. You have to create a new build, because you change in your POM the version number and you get a new hash key. Everything there is really messy. You do the things twice, 3 times and more. And to avoid this huge administrative doing, simply follow the semantic versioning. Then when you are talking with production, everybody knows when they find a version number with a very high, always use the most highest patch level. That's all. Another topic is the label. So as I already mentioned, don't write release candidate, alpha, beta or something. Just put additional snapshot. That marks your code is still in development mode. This is something we get from Maven. Now it's very common. And after you remove the snapshot label, you still have a release. Doesn't matter you use it in production or not. It's a release. And for that reason, I want to mention new wording. Because go away from the word release candidate. Because everything we produce and storage into a system like Nexus is still release, because when I have a GAF parameters like Maven, artifact ID, group ID, version number, everything together, create a release, and by default you just can have one artifact with those coordinates. You cannot have more than one, because how your Nexus system should distinguish what they have to deliver. In this way, everything in Nexus is a release by default. But this we talk a little more detailed in the next slide. I want to mention, if you are starting to deliver the first release of an artifact, and you have the sensation this is already having all the necessities for moving to production, call it production candidate. Because when the release, and don't label it, just go, for example, the release 2.3.0 called production candidate. This release we want to have in production. Pass all your quality stages, and then when you reach something like 2.3.4, after 4 iterations everything is fine, then you can move this into production. And this production candidate 2.3 already is fine, and you don't need to rerun any build or something. So this is why I want to talk about something like release, deploy and deliver. As I already mentioned, a release means I remove the label. I have something like 1.0.0 and I already package. Like in Maven, I run my Maven deploy, so all the integration tests, all the unit tests is running, is passing. I have my WAL file or my jar file, and this goes storage into Artifactory or Nexus. And then in this way I have the release. The artifact itself with the final version number is the release. And the way to storage this in the version in a repository management system like Nexus or Artifactory is deploying. So you could say storage. In this way we see release as a package, and the package will be stored as a deploy. So because the deployment means this could now consume from other projects. And you could say, I don't want that they are good consumed from other projects, but it's wrong. Why? What is with the test team? They are not put tests into your code base. No, they have their own repository where they use your release project as a dependency in a POM file, and then they write the test code around. In this way we have a consuming, and for that reason deployment is push it on Nexus for consuming everywhere else. And then we come to a delivery. Delivery is an installing, but installing where? And there we see the graphics on top. Yeah, we can deliver in a QA stage or we can deliver in production. And this is a very important thing between the words continuous integration, continuous delivery, and continuous deployment. The continuous means full automated, but don't think you have to initiate somehow and then everything is done. Full automated is not always like this between QA stage and production, for example. You don't want to have a full pass from commit, CA, QA into production. You want to have a gatekeeper between QA to production. That minimum you have to push a button for your automation pipeline, because imagine you have some issues in your artifact, the server is not coming up, the QA stage is for some reason passing, and you crash the production. This we want to avoid, and in this way be careful. Don't automate everything because you just want to automate, and really be careful with the things you're doing. And another topic is continuous integration. We will talk a little later about what means testing, because continuous integration have different views and is not just running everything in Jenkins. But this we talk a little later in more detailed. In this way we come for the first practical gap in project automation DevOps architecture. Often when I join to projects, the companies tell me, Marco, everything is fine, you just have to optimize our Jenkins build jobs because they run too long, or we have some issues and the process is not that like we was expected. What I find often in these projects are something like you see here in the graphic. These are very heavy architectural gaps. So imagine this graphic is a huge web application spread it around in 4 source control repositories or Git repositories. We have 5 artifacts. For example, the artifact B defines an API, and A and B is a multi-module project in one repository. So in this way, for example, commons is a regular dependency we use everywhere. It's very typical, it's not so complicated to deal with it. We already have a lot of experience, and even with the first line artifact A and B, it's without any problem. So if you're compiling your first project A and B together, you have to aware that as first commons exist, and even the version you are using in your artifacts. So more complicated is with the line of artifact D, because this consumes the API of your first project. So you always have to be careful which API version you are consuming. For example, if you upgrade the API version, then you have to be aware that artifact B already is in the correct version available in your source control management system, in your Nexus. So, because these are two different source control management systems, if you run these build jobs in Jenkins, you could say, okay, well, I want to have an orchestrated build. No, in this way you don't need. Just be aware that the API artifact B is always available in the correct version. And if you deal there with semantic versioning, your organization and your managing is much more easy, because you don't need always to check, is this version is compatible, if I have to check it. And simply if you see, okay, of this artifact B I get a new minor or major patch level, I can upgrade without any problem. Should work, because there is just additions in between. I just have to care if I have major updates of artifact B, and then I have to adapt my artifact D. A big issue is artifact C. Here we see a misuse of commons, and in this way, this transition between or this relation between commons and artifact C you have to remove by default, because sometimes I often see that in real projects. Now, yeah, what that means, it's quite simple. For example, imagine artifact C have something to do with user management, and you want to use there of this thing in commons a functionality. Now, yeah, then you get exactly this relation. You have to remove it by default. There is no way. If you have always this kind of relation, you have to check your architecture and you have to remove it. If not, you get in a huge trouble. Maybe not directly, not in the first moment, but later. This will cause you a lot of troubles. And don't think this is not there. Almost every project I joined, I find this kind of relations. So be careful with it. In this way, we want to just fast think about it, how we can fix our build. As first, build logic have to create or written or maintained by developers, not by administrators. They usually don't know what they are doing there. Really, believe me. And the administrator is by default in the DevOps team operation. No, that means also your DevOps team have two type of persons, developers and administrators. For me, for example, I'm a developer. I know how to write a efficient build logic. I know how to deal with that. Administrators usually not. They have a completely different view about applications. And they, for example, they are expert in the VI editor. They are expert in Linux systems and to run Puppet script, Chef, and all these kind of tools. With me as a developer background, I'm not dealing usually with this kind of topics. I know it, but this is the administrative work. For that reason, you need these two stereotypes of persons in a DevOps team. So that means by default, a DevOps team minimum have two persons, but practically much more. So, but don't create a DevOps team always with just administrators, because I always see the job explanation, job descriptions of companies, and they usually search for administrators in DevOps, and there is no developer present inside of these teams. The solutions sometimes are a bit critical. So, by this way, follow the KISS principle I already mentioned. Keep it simple, stupid. Always try to avoid dependency changes, because if you have a lot of dependency chains, this marks you are dealing with a monolith. And of course, you could spread around the monolith in several Git repositories, but this makes life much more complicated. In this, in this relation, you will fall sometimes in the need of orchestrated builds, and orchestrated build always is evil. You have to avoid it because this gives too high complexity to your build logic, and one day you are not able to maintain it anymore. So another very good advice in the way to dealing with build logic: don't do anything at once. For example, in Maven, use profiles. If you have a default build for developers, if you have an integration build for integration tests, if you have there some a release build for creating your API, if you have a profile for running your Maven site to get to know all your issues for instrumentation, bug fixes, and. So, for example, in the way of Maven, deal with profiles. Every step you're doing, create your profile. Don't do everything at once, because this will cost you a lot of troubles to maintain everything. No? But there we already did the first way of typical gaps. Another gap we have is a single point of failure. Single point of failure, what that means? Version numbers. Usually, if you're dealing with Bower or NuGet and Microsoft.NET, you have to combine so many different build logics, and they are by default not synchronized. And in Bower, you don't have represented in your code or in your artifact, even with .NET, the version number. And this makes difficult if somebody is renaming the artifact and erasing the version number. So it's very difficult to get to know which kind of version number you're dealing with it. And for Maven, I always recommend this simple solution, how to make available the version number in my artifact programmatically. I'm dealing with token replacement. There I have a small own project in GitHub. You see here, I will open this very quick in an editor. Here, this is the Maven project. The version number is written down in the POM file, 1.0, 1.2 snapshot. So you see it's still in development. Then we are dealing with the resource plugin. So we activate the filtering for the resource plugin with this. These two filters we are not needed for the version number. Just this part, and that's all we have to do in the POM. The next point is we find here our version number properties. It's open in this file, and just one entry, version, and this is coming from the POM. And when I run the build with the token replacement, with the filtering, this property get replaced with a version number in the POM. So single point of failure. And then I have a small logic here with a property reader is also part of this project. You can see it here. This simply read the property file. You can see here. This is reading the property file, add it to the properties. Then I get the version number. This I'm storage here in the version number constraint. So this I can use everywhere in my program. This I can move into a main function. You can check it by command line. So to see that everything is working very well, if I open here the core jar I was created, you will see here, if I open this a little, configuration, voila, version properties, you see there is a replacement. That's already all in the way of version numbers, and very easy to do. So another topic we have is source control management. Source control management is a difficult part. What that means, often it's getting crazy because of all the branches we have and merge it. So here we see a small citing of a research paper written in 2011. Even advanced developers, they always get in trouble with merging. Now, yeah, why? If you are thinking about this, we have, for example, our main branch where where the development happen. So we are changing the version number snapshot into a release number, and then we prepare the release, we mark it. After this, in the main branch, we create a new commit or revision with a new version number, depends what is to do. For example, here we see 1.1 because we start with the next implementation. In between, the release 1.00 is in testing, and in the case they find some problems, so you have to create your branch and just make your bug fix. And this branch, you see when we merge it back in the main, this have a minimum delta of changes because I'm just working in the fix, not in all the code. By default, as less changes between two versions of a file, as much secure is that you don't run into a merge conflict. If you just have 2 or 3 merge conflicts, you can handle them manually. But if you're making a merge on their core 1000, 2000 conflicts, you are lost. This is almost impossible to fix it. Or it's impossible. In this way, here you have to always take care that you just get the most less changes between two branches. And if you are working parallel in two different functionalities, always merge or always synchronize from your development branch to your feature branches. In this way, you avoid a lot of troubles. It's absolutely mandatory. That's all what we have to talk about source control managements because, naja, they happen often and they are really, really, really problematic. Another topic is source automation server or CI servers, something like Jenkins. So in this way, we see now a very typical Jenkins DSL. It's very nice. It's very happy. A lot of people, a lot of managers want to see these nice boxes, but I'm not really a friend of this. As you see here, this is a regular release pipeline, and like a pipeline it is, it's a queue. And when a lot of things or when something in the queue get wrong, the whole build is fail. But for example, you see they are creating API docs. When the part API docs fail, the rest should run, and you should have an own job that you make able to create the fixed API doc. Then you don't need to run all this pipeline because some huge projects to run this pipeline takes sometimes 30, 60 or 90 minutes or sometimes more. And when your pipeline crashes in the last step, is not that nice, and so for that reason it's very helpful to have very small build jobs and do the things in parallel, like here. In Jenkins, you see with the Groovy DSL there is a very small instruction to make it, but even there I'm not so happy with this build pipeline plugin of Jenkins, because if you see that here, so let's check it. I have it open. Should have in my web browser, because no. So because the biggest problem we have there inside is voila, come back. So no. what we see here in the parallel. When something went wrong, like I prepare here, you can see all the parallel job is crashing too. There with the logs, you see, okay, well, there is missing one thing, yeah, beside the three steps we was having. So, but the deploy is not working too. And here I miss, okay, well, I should see, or I want to see what kind of job is crashing, so we don't get any information about it, no? Because original should look like this, like sonar, no? And it's much better if you are creating single build jobs, and you can orchestrate the single build jobs then as a pipeline. This avoids you a lot of troubles. You can rerun after something is failing, and you just can search exactly in the point of your job what is failed. So in that way, try to create a simple job as first, integration that it runs, and then the others. So there we come about testing, because this is something we have to think about it when we are creating build pipelines. Testing. So, for example, if we deal with Maven, there we have two test goals inside, integration tests and unit tests. Unit tests are done by Azure Fire plugin, and integration tests by Failsafe. The point is, unit tests should be really atomar, very small, and don't have any REST calls or something. Sometimes the integration tests of your artifact, this could be calls to databases, this could be calls to RESTful background services, because they are taking a lot of time, and so you are able to do it full tested during your workflow, but later when you're dealing when you run it in your complete environment, you can deactivate it as a developer. Then you don't need always, when you run a compile, you don't need always have to run the integration tests, because they are very low performance. And sometimes I'm reaching projects on the compile time, everything goes really quick, so with 5 minutes everything is done, but the tests they are running in the background for a module takes 20 or 30 minutes, because they try to check database rollbacks and other things. So avoid it. Integration tests in that way, they are for team collaboration in the way of Jenkins. Yeah, because you want to see that your code base in Git is correct. Nobody was missing submit a file. Well, this is the point. Another topic of integration tests is when you deal with tools like JGiven or Cucumber, where you put together a lot of artifacts as a whole application, and then you can run their behavior-driven tests. They don't need to test everything like in unit tests, because with a high test coverage, you already show that the implementation is working fine. Another integration test idea is check with a nightly build when you're dealing with web application if the server is coming up. Because if you make some changes in the web XML, you will not have this covered by regular tests. You have to create your artifact, you have to move it to your application server, and you have to start it. And in this way, you have the zero level of integration tests is inside of your application, something like database connections, something like RESTful calls. Second way of integration, the first level then of integration tests is on Jenkins. Check that your source control management is correct, your Git repository is not broken. And the third level is install in a environment to see the server is coming up. And the fourth is behavior driven with tools like JGiven and Cucumber, done by the test team, but also automated by tools like Jenkins. So there are some other test aspects we want not getting too close because this could be an own presentation. Um, with this way, we already see our 5 positions of testing we already done, and in this way we should put together what we think, what we learned in DevOps to make it well performed. So as first, work with a well-structured architecture. This simplifies your life extremely. Um, Source control management is a collaboration tool, in my perception. Don't deal with these pull requests in enterprise projects. Source control management is not a quality gate. So don't create high sophisticated own solutions. Don't build around Maven a own platform to to get away from the standards. Always follow the common standards because this helps you later when there's coming new technologies. Always to integrate them because if you have your own solution, well, you have to modify everything that is working together with new technologies. And then, of course, try to prefer decentralized solutions. That means if you have a huge project, web application 1 and web application 2, create a Jenkins for web application 1 and create your own Jenkins for web application 2. This reduces your administration overhead. Gives a little more security that the people are not crashing from project A things in project B. And if one Jenkins is crashed, the other project can run, can continue development. And of course, avoid perfectionism. Don't be a perfectionist because with this, you never be, you never come to an end. And in this way, failures, they always happen. We are humans, and this is okay. But the most important in DevOps is we want to detect problems so soon as possible. Doesn't matter if it's continuous integration, continuous testing, continuous delivery, continuous deployment, continuous whatever. The word continuous mark, we do it often, and for that reason we detect very fast if there are some issues. In this way, I hope my presentation for you was interesting. You could get some new information. Thank you for your attention. See you as next. These slides you will find on speaker's desk. Ciao.